Hi, I'm Mr. MegaTronic, and this is our Maker, and welcome to Panda Plastic. For 3 months in 2012, I was designing a 3D printed 3D printer. What's more, he was designed to look like the mascot for the MakerBot company. It's a long time coming for this video, but I'm finally ready to share the files and the story. So let's just get straight into the CAD and let's talk about it. Back in summer of 2012, I received out of the blue a MakerBot replicator from the MakerBot company. Now, I received this basically as a courtesy promo for having last year won the competition to design the mascot for the MakerBot company. This little guy called R Maker. Now, there was a bunch of other excellent designs in that competition, but my design won out, and it became the mascot of MakerBot. It was used in a lot of little stop motion clips by their marketing department, and it was a fun little moment for somebody who had never designed anything for 3D printing, let alone seen a 3D printer in person. And that was literally the first thing I ever did in Autodesk Inventor as well. So there was a lot at stake whether this was to work or not. But surprising me, it actually wound up working, and I won the contest. And a year later, I received another printer. Now, it was exciting and surprising, and I wanted to say thank you, basically. So I had an idea, and the idea was to design a 3D printer that would resemble the mascot. However, what I wanted to accomplish was that the printer itself was made from the exact same parts as the Thing-O-Matic, which was the printer I received first. That way, were somebody to have the Replicator, they would be able to dismantle a Thing-O-Matic, print these parts, and reassemble the Thing-O-Matic as the R-Maker Special Edition. So I had the idea, and I was knocking it around and doing a few tests when I got a hold of Bree Pettis, and the then CEO of MakerBot, and he loved the idea. So he commissioned me to finish it. In November of 2012, I even flew out to New York, where I would present it, and got a tour of the place. And I was very very impressed by the place and all the talented people who worked there. But I digress. This is about this design. Only one was made, and it took me a few months because I was designing it as I was printing it due to time constraints. So what I want this to be is, this is kind of the bookend to that story, which is something I've wanted to do for a while, and now I have time and the wherewithal to actually get this done. So without further ado, we're going to go over our Maker Special Edition. Now, and I'm going to show you what I did and the decisions I make regarding how to make it, because this is by no means an efficient 3D printer design. It absolutely is not. If you were designing a printer for printer's sake, all of these conventions go out the window. But the reason why this was designed the way it was is I wanted there to be no additional parts other than a dismantled Thing-O-Matic. And it was an arbitrary constraint, but it was one that I felt it had a meaning. It had a purpose to it. Moreover, it gave me kind of a platform to work from, and I had real components to measure against. And there was very few needs for reprints. Step by step, it kind of worked out, and I was surprised. Fun little fact too. There is a documentary called "Print the Legend," which talks about the rise of both MakerBot and Formlabs, and in a few of the shots, you can actually see the design I printed in the on the display case in the entryway of MakerBot headquarters after they moved to the Metro Tech Tower. So that's fun little tidbit. I actually, a couple more of my designs are peppered throughout that documentary, which I don't know if it's still on Netflix, but it was on Netflix for a while, as well as being seen at South by Southwest. So anyways, let's get into the design of this. So I'm first going to go through the inventor file here. Oh, and by the way, all of the files of all of these parts I'm going to be putting onto the Thingiverse finally. I have a item on the Thingiverse right now, but it only has one part on it because I've wanted to have at least a video describing this, because there's so many parts without like instructions on how to put it together. I was disinterested in having just a stack of parts there, and good luck putting it together. So while I won't be making written instructions on how to do this, this video I would hope would help kind of put it into perspective, and somebody who is willing to print and assemble one of these to blow the dust off of their old Thing-O-Matic, by all means. So I'll show you some pictures of the assembly of the original one after we go through this model, as well as a few videos of it in operation. Let's get to it. So this guy. So let's just take a look. So it's actually larger than it looks. Relative to the size of a replicator. Here's an image there. There's a replicator right next to it. It's actually a little taller than the replicator, a whole head taller. It's about the size of the Thing-O-Matic plus a head on top. Now the head is cosmetic. It doesn't have any purpose, but I'll just go through this. So this is the MK7 extruder, and it uses the same attachment plate. It uses the same through rods as well. One of the things that I did a lot in this is I used a hexagonal indents to act as captors for the nuts. Now the replicator used square nuts, but the Thing-O-Matic still used hex nuts, because the square nuts on the replicator made for better T-slots. But on this guy, since the parts came off of a Thing-O-Matic, it used hex nuts. This is actually a little bar that you can zip tie the cables to, so it allowed it to keep it tidy. So the wads of cables didn't get crowded inside of here, because it's actually smaller on the inside than the Thing-O-Matic was. I tried to actually make it fairly compact. Uses the same 3-rod Z-axis. It has the 2 idling bearing rods and the screw itself. Now, one of the things is, like, you can see here in the back, I've made a channel that the wires for the Z motor would follow along, and it actually has notches in it for zip ties. Zip ties would go through these notches here and here, and it would help secure it. I mean, I kind of went out of my way to make this thing look less and less like it was slapped together, and more like it was an engineered product. Here's a vent in the back to allow air to pass through. It really mattered when you're printing with PLA. This is early in the world of 3D printing, and ABS was still very common, but PLA was coming out, and it made for great prints. So this used the X and Y gantry that would move on its own, and the Z would only move up and down. So there's a belt clamp that actually is not visible there, but it pinches on that belt. There's the clamp for that belt as well as its gantry. It's small and light enough that it can at least hit the end stop, which I believe I put see, the Z end stop. Where did I put that? It's been a few years since I've looked at this. I put the Z end stop somewhere. Oh yeah, that's right. So there's 2 holes. No, that's for the mount. That's for the motor mount. It's around here. Once I start turning parts off, we can see it a little bit better. Now, the first component that this whole thing had was actually a standard ATX power supply. All of the Thing-O-Matics used just an ATX power supply, so it started with the mounting of this, and then that followed into that followed into this foot, which became an anchor point. Then this corner. Now this is where things got very interesting. I designed this entire body to not use support materials at all on a Replicator first generation. Every single part on here is designed to print in a specific orientation, and that can be pretty much assumed. So like right here, you can see that there's these angles that allows for basically it to ramp up, which means this part gets printed in this orientation. If I selected this body, you can see right there, this guy. He gets printed from this position going straight up. It almost fills the vertical height of that build area, but it fits right in there. But it builds a corner, and it's one solid piece. And the importance of that is that when this piece intersects with it, it makes a very strong corner. And that was kind of, I was impressed. This actually printed better quality than the wooden enclosure that that the Thing-O-Matic originally was, which surprised me. But considering how many parts it was, but it's designed to basically create enough constraints around itself that it doesn't bind or flex nearly as much as it would otherwise. These are the screw holes for the Z end stop, which winds up going right here. The end stops I don't think I modeled into here. I just had a specific dimension on it. But that's the rest. You back out. That's the rest that would bump up against the switch when it was doing its Z homing position. There's the spool holder. Now, the center actually is a spine. You can see from the inside much better. This is an L bracket that goes straight up. This is the back of the spool holder, and it goes straight up and mounts right to the motor for the Z screw. And that spine was really important because to have that single vertical piece on the most important mechanism that lifts this whole thing, that was intentional to keep it structural. Up on the top, you could see a lot of these have voids in them, and that's basically just to conserve plastic. One can argue it adds strength to it, but the main purpose of it was for it to conserve material, because it still used in this whole entire printer. I used 3 full spools, 3 kilograms of silver, and 2 kilograms of red. And I actually still have some of the fluorescent yellow left from all these years. This is a cosmetic piece that goes in the front. It just kind of encloses it off and gives it a nice framing. The whole purpose of it was to look like our Maker, so that's his characteristic front. Now, some things I actually made hollow because I wanted to put LEDs in, so it could actually illuminate the eyes also. The whole head is hollow. It serves no purpose other than to be a head. There's a little bit of ventilation in the back, which was just a fun thing to add. But this is where the filament actually feeds in. You'd put a plastic tube, like a PET tube, out the top, and it would come down and it would hold in this position over here and allow the plastic to be fed up on the filament spool. Now, let's see. The arms, again, they also don't function. They rotate up, and you can swivel the claws, but the claws don't open and shut. They're merely cosmetic. Electrically is where it gets interesting. So this is the LCD brain, but also in the original Thing-O-Matic, the board was all the way at the bottom, right near the ATX power supply. Well, without changing the lengths of any of the wires, one of the things that I managed to do, let me remove or hide that. And then on this part, I will hide this. Boop. You can also see embossed in the body is X, Y, Z, and A. These are the stepper boards, and the reason they're in this position is because the cables that the Thing-O-Matic had pre-cut could only reach to a certain distance. So these were positioned in the locations where the cables would have the greatest chance of making it. Now these are the 4 stepper drivers when because the Thing-O-Matic actually used these discrete drivers for each stepper. They mount down here, and then their cabling comes up through the inside and feeds through here into the back of the MakerBot motherboard, which is, you know, Thing-O-Matic coupled to an Arduino Mega. So this is the faceplate, and this one was probably my favorite thing to do because I always like user interfaces. But these buttons I was particularly proud of because right behind here is the LCD panel, just with their caps removed, so the buttons are directly behind it. Right here. See, were you to take apart the LCD accessory for the Thing-O-Matic, you would find these 2 parts. And then this was designed to, without any modification or soldering, take that same thing and reclothe it in something fairly attractive. And the buttons felt good too. I really liked the tactile sensation on these. So it really did make it feel, you know, fairly complete. But here, let me hide this guy. Boop. And then this is a adapter plate that kind of holds everything in position. Boop. And then this is the button array. Boop. Console screens. Boop. All right. So right here is the actual motherboard. I'm going to hide this part too. So this is the Arduino Mega. Coupled to it is the MakerBot breakout board with the SD card slot and the buzzer and the reset button. But also it has the secondary board that drove all the heaters and everything else. So there was the RJ45s. I'll show you a photograph of the actual assembly when I get to that point. But the other benefit of having all these goodies up front is that the SD card slot, the USB, and the power, well, you don't have to feed power to the Arduino, but the reset button, the SD card, and the USB were all up front. You know, that was probably the most obnoxious thing for me, was that I had to, on the Thing-O-Matic, reach all the way in the back and grab grab my SD card or hit the reset button or whatever. But this brought them right up front, so they were easy to get to. After these major parts came into existence, everything else was consequentially modeled. Basically, all the little gaps I had left, I had to do something. So there's like these braces that fuse the 2 sides together, the front and the back. The foot on the other side was basically just it needed to have another foot, so I designed another one and just kind of fitted in there. Most of this was just battling kind of the challenge of taking things that already exist, things that don't exist, the limited build area of the Replicator, and then trying to make something that was okay enough to use. Right here is a side panel. This is one of the last things that was added. This little access panel right here is actually there because the tensioner for the X gantry, the X axis, I needed to have access to, but it would have been so horrible to take the whole thing apart just to be able to tighten that belt. So you remove that panel right there, and then you can access this screw right here, and that allows you to tighten it, which pulls the pulley tighter and tightens up that gantry. Same thing with this belt down here. To tighten it, there's an access panel right through there. That one covers the rod, and then you can access the screw through that. So, you know, it was a very involved model, but part after part, it came together, and I believe Bree was happy with it, and went to New York, shook his hand, and for I don't know how long, I don't even know if it's still there, but for quite a while, this guy was hanging out in the lobby. If anybody who worked at MakerBot or works there now, you know, is watching this, leave a comment and and a like, and let me know if it's there. So now I'm going to show you kind of the progress pictures of how this went down, and I can show you some of the issues I had, because, you know, this was still in personal printing's early days, and that was exhausting, especially because this whole thing is printed in ABS. So the Thing-O-Matic, the original Replicator, while it could do ABS, large ABS parts were very, very picky about temperature gradient, and as it would cool, as it printed, it would separate and split. So the original actually has quite a few splits in it that I had to either weld shut or reprint a few parts. But over the span of a couple months, I did manage to get these things printed out. Now, first I'll show you the last version of my Thing-O-Matic. So this guy here, this is the last iteration of my Thingiverse, or of my Thing-O-Matic, and it was modified quite a bit, as you can see, just before it gave its life to become the Thing-O-Matic Special Edition. So it had a much easier access all the way around, and it was still fairly rigid. I mean, it doesn't look like it should be, but it actually was, and it printed okay. So the first part that I wound up printing was this test part. This test part was the beginning of the spine, and I had a couple issues with the location of the tabs, and I also had some vibrations in the Replicator, so I was working through some of that, tightened it up, and got it much cleaner. And then this is part of the swivel that the head swivels across. There was a channel there. This is kind of showing where the cables would pass through, and then I actually started printing the actual parts. So this is the final. This is the beginning of the final parts. So this back foot has a hole for it that the rod would go through, and then here's the spine coming together. Although you can see here, the part began splitting. Now, this was a part that was hidden underneath the butt of another part, so I wasn't too terribly worried, especially when screws would wind up going through these two holes. Then it would start to come together. But over time... Yeah, here's another shot of that split, but it wasn't super structural, so I wasn't too concerned about it. Here's the back plate coming together. You can see a little bit of minor splitting on there, but this back vent printed okay, all things considered. First comes in the new corner. You can see in there it's sitting on top of that other part, so the split doesn't really matter too much as it comes together. Another angle of that same part in the same assembly. I mean, I was still really early to 3D printing, you know, when I was doing this, so I was learning a lot about the nature of printing larger parts especially, but it was incredibly exciting to watch this thing kind of take shape, especially considering I didn't have to have too many redos, which still surprises me. Here it is with the top on and with the end stop loaded, installed into it. It was at this point I was actually able to start moving it just to test the clearances of things. Let's see. Yeah, here's another shot with the with the spool holder on the back. And here's the other side put together. Now, you can see up there that brake, that is a failed part. That's one of the failed parts that didn't quite make it. But I still wanted to test the fit of everything and have that bar move up and down, just to make sure that it didn't over-constrain. That was one of the big concerns of mine, was that variations in the assembly would cause the two rods to be angled slightly, which would make it trapezoidal. So the bearings, or in this case the bushings on these rods, as they traveled up and down, they'd get closer together and they'd bind and become tight, and it would be too much work for the little stepper motor to torque it up and down. But in this test it was okay, and in the final one it was actually still okay. It actually didn't bind in the final, which was I'd say more luck than it was a feat of engineering, but maybe I'm not giving myself enough credit. There's actually a lot of superficial screws on here. I'll go out and say that. A lot of folks will say that there's a lot of unnecessary parts and a lot of unnecessary screws. I 100% agree, because as I disassembled the printer, I literally counted the screws and added just enough to use every last one, which sounds kind of silly, but this project was kind of silly. More shots of the wires managed through these zip ties. Here's a shot of the back as it's coming together. So you can see the, yeah, it's coming together. It is as it should. Let's see. Here we go. So this is where I was printing the bottom front, and all of a sudden the extruder jams. But I caught it early enough that basically I over extruded to get it caught up, and then I was able to pause and then continue. That's one of those hairy things where something's printing for 8 hours and then it screws up, but you've caught it just at that moment, and you're like, oh boy. But I was actually able to save this part and use it in the final one. I just kind of sanded it clean. Here's the bar for the cable management on the Z axis. And here's this guy put together with that bottom piece in place, and one of the stepper drivers installed, and the printed Z-axis plate and the wires with the cable management. So this is fun. I really enjoyed it at this point, because then I could get it moving up and down and watching it. There you can see the Y end stop down there. And here's a shot of the extruder on its plate. Uses the original thumb screws that came with it, and the fault protection circuits loaded on it, as well as the thermocouple. Here's cable management again. I was very proud of the cable management. So if there's one thing that I really enjoyed, it's the cable management. Sometimes I used longer screws, but then swapped them out for the shorter ones near the end. This one is actually needed to be longer because there was going to be a clip that would take up some of the length of that. Here we go. Now we're getting more of the stepper drivers loaded, and they all just fit where they're supposed to. They had the same little standoffs they used when they were mounted in the Thing-O-Matic. Boop. Another shot of them just kind of hanging out in there. Here's a rear end shot of a spool loaded on it. Here's a inspector. Here's my inspector just checking it out, making sure that it's coming together all right. He gave me the go ahead to continue. Here he is taking a break. He worked really hard. Okay, so it's coming together. Got the front pieces on now that finish the box. Now the box is rigid at this point. It has the rods inserted and the belt's not in, but it's pretty much structurally sound at this point. Here we go. Here's a view of the MakerBot motherboard and the heater control board. And they were side by side, and they were kind of tied together in this in this tight cable harness. It was kind of tough pushing it in, but it did wind up just fitting pretty well. So you can see it here, just kind of tucked in there. The green LED, it had white LEDs that actually went around the inside, and that was also one of the features that you could have gotten with a Thing-O-Matic that I kept in there. There it is with the stuff in it. It's checking the fit to make sure the USB fits and the reset can be pressed and the SD card can be loaded. And then there it is with the faceplate on. This is the test faceplate. The final one actually had a better looking one. This one was kind of rough when it printed. I had some jamming in the extruder, so there's gaps here and there. But yeah, this is warming up and starting to move around at this point. Another shot. There was a few parts not yet printed that were running on the Thing-O-Matic at this point. And now I took it apart a little bit more to do one final assembly to test the fit of things. One of the challenges was, as I was putting it together, it started to bind on itself and create constraints where there was none, because as you work your way around, you're creating tension as you tighten it. So what I had to do was, as I was assembling it, I was actually assembling it loose and then systematically tightening it in regions until the tension would be equalized and all the rods slid up and down without resistance. That was important because otherwise it would start to get tighter, and then it would compound that problem and it would get out of control. So coming near the end, this is with it almost assembled, doing some final tests. And then here he is almost with his arms, and he doesn't have his eyes installed yet because those were actually intended to be the test prints on this thing. I refrained from printing eyes on it, and that's why the spool on the back was always the fluorescent spool, because that was kind of the reminder, is that he's going to print his own eyes. And that'll qualify it as an actual printer. Here he is with his arms, and he's almost ready for action. Here he is next to the Thing-O-Matic, the replicator that had exhaustively printed out all of his parts. And it's crazy to think that that whole thing there, part by part, came on that little build platform in the replicator. That came from that. And it still surprises me today. Here he is printing his first eye. In fact, I'll show a video of that. So yeah, he succeeded in printing his own eyeball. There's the cleaner plate on the end, the one that went with it. It's a lot cleaner looking. There he is next to his little guy. And then yeah, so he went on to New York, and he was in the lobby of MakerBot, greeting everybody as he came in. Now I'm going to put all of the STL files for this guy up on the Thingiverse finally, and hopefully from this video you can kind of understand and examine how to put it together. But if you have any questions, ask in the comments, ask on the Thingiverse. I'd be glad to try to help the best I can. But understand, this is a very long print. This is a marathon. This is going to use a lot of plastic. It was originally designed for ABS. While it could be printed in PLA, I would wager that new issues could arise from that. Things like build plate adhesion, even though PLA is okay with that generally. It all depends on your printer and its ability to print. All of these parts were designed to maximize the build envelope of a Replicator 1, which means a Replicator 2 will be just fine. And the new series, the 5th gens, should be okay. Not the Replicator Mini. And any third-party printer that has a build area that's bigger than a Replicator 1 should be just fine, like Ultimakers and Pruses and things like that. So the i3 and blah 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 blah, FlashForge, Solidoodle, whatever. You should be able to print this based on the files that are here. It used the last edition of the Thing-O-Matic using the Mark 7 extruder. So you may have to make some modifications if it doesn't use the same brackets. And this was intended for one that was unmodified on the hardware level. I mean, I modified the wood on mine, but everything else was original. So just bear that in mind. It's a project, and I can't guarantee success with it. But those that are motivated enough to make one, go for it. And I'd love to see that done. I'd love to see more of these start to appear in the wild. So that concludes this episode of From Pen to Plastic. The next episode is going to be a new project, and I'm looking forward to getting it up. But if you like this one, like, comment, subscribe, share. I'm trying to get over that hump of having almost no subscribers. YouTube won't even let me have my own URL if I don't have at least 100 subscribers. So do me a favor and get the word out, and then I can, I'll know that people want to see more of this stuff. So thanks for watching, and I will see you next time. Bye.